So we are looking at the pre-algebra final exam review packet here, and question number 1 asks us to select the expression that is equivalent to 5 times 5 times 5 times 5. This is an exponent problem. Remember, it's your base, which my base will be 5 times, and it's 5 times itself 4 times, so B will be my answer here. We're working the opposite way on 2. My base is 6, so it's 6 times itself 5 times, and that gives us an answer of C. Question 3 has us select the expression that is equivalent to 7 to the negative 4th power. 7 up to, anytime you have something to a negative power, you move it to the denominator and then make the exponent positive. So C would be my answer for 3. Again, you just move it to the denominator, make the numerator 1, and the exponent becomes positive. Question number 4 also involves a negative exponent. So when you have negative exponents in the denominator, you just move it to the numerator and make the exponent positive. So it'd be 5 squared over 1. 5 squared is 25. Divided by 1, 25. Divided by 1 is just 25. So our answer here is C. Question 5, when you are multiplying two numbers with the same base, you add their exponents. So this should be 2, and then you have 3 plus negative 2. So you have 2 to the first power, which is just 2 by itself. When you're dividing exponents and the numbers have the same base, you subtract your exponents. So it'd be 6, and then 4 minus 2 would be 6 squared, and 6 squared is 36. That'd be A. You can also look at it and write it in expanded form. And then cancel, 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 and you're just left with 6 times 6, which is also 36. Question 7 has us evaluating the following. On this first example, it's saying negative 3 to the second power. This is asking really the opposite of 3 squared. So if 3 squared is 9, the opposite of that would be negative 9. This is a little different on the second one. This is saying the negative 3 is in parentheses, so I need to take negative 3 times negative 3. Negative times a negative is a positive, so I have positive 9 for the second one. When you have the bars around this, remember that is absolute value. So you're saying, what is that number's distance from 0? Again, distance always being positive. Negative 2 is 2 from 0, 2 units, so it's just a positive 2 for the absolute value. This fourth one says the opposite of the absolute value of 2. That negative is on the outside. So if I have the absolute value of 2 is 2, and then the opposite of that for that negative, my final answer is negative 2. Anything to the 0 power is 1. Remember, when you have a negative exponent, you make the numerator 1, move it to the denominator. So you have 1 over 4 to the first power, which is also just equal to 1/4. Down here, we have 5 minus negative 2. I'm going to change it to an addition problem and change my second number to the opposite, or we've heard keep, change, change. So I have 5 plus 2, and that gives us a final answer of 7. Same thing for this problem. I'm going to keep, change, change. That becomes 8 plus negative 12. I have more negatives than I have positives, so I know my answer is going to be negative, and I have 4 more negatives than I have positives. So my final answer is negative 4. Question 8 is all the order of operations. If you remember, those are PEMDAS, parentheses, exponents, multiply or divide, whichever comes first, left to right, and then add or subtract, whichever comes first, left to right. So on this first problem here, I'm looking inside my parentheses. That's my P. Inside my parentheses, it's like its own order of operations problem. So I have 3 times 2 in here. That's going to become 6. So I then copy my 6 down, and then I have 6 minus 8 squared. I'm still working inside my parentheses. On my next step, 6 take away 8. So if I have $6 and then I spend $8, I'm left with negative $2. Still square that, divided by 2 times 4. Negative 2 squared, that's negative 2 times negative 2, that's a positive 4, divided by 2, because I'm working on my exponents now. I have no more exponents, so I'm multiplying or dividing, but whichever comes first, left to right. So I see division first from left to right. So I have 4 divided by 2, that's 2 times 4, to get a final answer of 8. We are still working through PEMDAS on here, or order of operations. On this problem, I don't see any parentheses, so I'm going to move on to exponents. I do see 2 to the second power, so that becomes 4, and then I copy everything else down. No more exponents. I'm working through multiplication or division, whichever comes first, left to right. On here, I see division first, so I'm going to take 8 divided by 4. That becomes 2. Copy everything else down. Now I do my multiplication. That becomes 4 minus 5 plus 4. Now I add or subtract whichever comes first, left to right. I see subtraction first. So 4 take away 5 is a negative 1 plus 4. Negative 1 plus 4 is positive 3. Again, working through PEMDAS, I have 5 plus 2 cubed times 4. Inside my parentheses, I'm going to work through my exponents. So 2 cubed becomes 8. So 5 plus 8 times 4. 5 plus 8 is 13 times 4. And that is a final answer of 42. So working through PEMDAS, no parentheses, no exponents. I'm going to multiply 6 plus 3 times 2 becomes 6 divided by 6. 6 divided by 6 is 1 plus 6. 6 plus 1 is 7. So the first part of problem number 9 says a negative times a negative. Remember, if we draw our little face here, if we have 2 negatives, the answer will always be positive when you're multiplying. Now, when you have a negative plus a negative, if I'm taking a bunch of negatives, adding them to more negatives, my answer again will always be negative. Part 3, it's a negative times a positive. My answer in this case, again, will always be negative. And then lastly, a negative plus a positive. So if I have negative 8 plus 3, I'm left with negative 5. However, I could do negative 3 plus 8, positive 8, and that gives me a positive 5. So when you have a negative plus a positive, depending on what you have more of, it can either be positive or negative. Problem 10 asks us to evaluate the expression given the value of x and y. So I have 6x plus 3y minus 2, given x equals 1 and y equals negative 2. So wherever I see an x and a y, I'm plugging in 1 and negative 2. So I have 6 times 1 plus 3 times negative 2 minus 2. And now this is just an order of operations problem. I'm doing I have no parentheses, no exponents. I'm going to multiply first from left to right. So I have 6 times 1, so that's 6 plus 3 times negative 2 minus 2. Then I multiply the 3 times negative 2, so I have 6 plus negative 6 minus 2. And I'm going to work from left to right. 6 plus negative 6 is 0, so I have 0 minus 2. So 0 take away 2 is negative 2 for my final answer. Doing the same thing on this next one. Negative 3 squared minus 2 times 3. Because my x is negative 3 and my y is positive 3. On this first part, negative 3 times negative 3 is a positive 9 minus 2 times 3. Again, still working through PEMDAS, so I'm going to multiply. I have 9 minus 6. Then 9 take away 6 is a final answer of 3. So on this last problem, we're doing the same thing. So I have negative 3 times 2 squared plus 4 times 6. Again, I'm working my exponents first. Negative 3 times 4 plus 4 times 6. Over here, that becomes negative 12 plus 4 times 6. Remember, I work left to right. And then I have negative 12 plus 4 times 6 is 24. Negative 12 plus 24 is a positive 12. Problem 11 says to simplify the polynomials. What they mean by this is, yes, we'll need to distribute if we need to, but then essentially the easier way to say this would be to combine like terms. First thing I'm going to do is multiply my 5 times 2 and negative 4 because the 5 is on the outside of the parentheses, so I'm distributing here. So I'm left with 10x minus 20 plus 3x plus 10. I can drop the parentheses on the second part. Now I'm just combining my x's and then my constants. So if I have 10x plus 3 more x's, I'm left with 13x. Negative 20 plus 10 is a negative 10. On the second one, I'm taking this negative, and imagine there's a 1 there. That goes times everything on the inside, and then this negative 2 here goes times everything on the inside of the second set of parentheses. So I have negative 6 minus 5 plus x squared. Essentially, all of these become the opposites because you're multiplying it times a negative. And then minus 6 minus 2x squared plus 4. I'm taking negative 2 times 3, negative 2 times x squared, and negative 2 times negative 2. Then I have x's, so this should actually be negative 6x here. Then I have x's, x squares, and constants. To be most mathematically correct, or the most like a mathematician, I'm going to start with my highest exponent. So that's my x squared. So x squared minus 2x squared, so that's 1 take away 2, so that's a negative 1x squared. I like to cross them out once I've used them. Then I go to my x, there's just 1 by itself, so minus 6x. And then I have negative 5, negative 6, and 4. I'm just going to add all those up. That's negative 11 plus 4, and that gives me a final answer, negative 7. So my final answer would be negative x squared minus 6x minus 7. This last problem, I have x's, y's, and constants. I'm going to start in alphabetical order, so I'm going to do my x's. Remember, there's an imaginary 1 there, so I have 3x plus negative 1x. That gives me 2x's. My y's, 7 plus negative 6, so that's just 1y. And then I'm left with 2 and negative 4, so 2 plus negative 4 is negative 2 for my final answer. Problem 12 has us solving the following equations. Our first 3 are one-step equations here, so we don't necessarily need our orange checklist. So what I like to do is I like to circle my variables so I know I need to get that by itself, so I need to move everything else. I draw my fence, and then I start doing the inverse operation. So if I have x minus 2, to get rid of that minus 2, I need to add 2. And what I do to one side of the equal sign, I do to the other. So then I'm left with x equals negative 7. And I lied, the second one is a two-step equation, but I want to get x by itself. So I have a positive 4 minus x, so I need to subtract this 4. Think, what do I get these numbers to get to 0? So minus 4, so I'm left with negative x equals 8. There's an imaginary 1 there, so I need to divide by negative 1, divide by negative 1, and I'm left with x equals negative 8. Here I have negative 6 times x equals negative 18. I need to undo that multiplication, so I'm going to divide by negative 6, divide by negative 6, and I'm left with x equals positive 3. I have x divided by 4 equals 8, so to undo the division, I multiply, just multiply on both sides, cancels, x equals 32. The next problem, this time we have variables on both sides. So if we're looking at our solving multi-step linear equations checklist, that orange paper, we can skip step 1, and then step 2 says to combine like terms, because step 1 we can skip because there's no parentheses to distribute. Step 2 says to combine like terms on both sides of the equal sign. If I look on the left side, I just have a constant and my variable, same thing on the right side. So I'm going to move to step 3, which says group variable terms to one side of the equal sign using inverse operations. Remember, I'm going to pick the side with the biggest variable to make my variable side. So I'm going to make the right-hand side, because 3x is greater than 1x. I'm going to make this my number sign. So I need to move this x over to the other side. So I'm going to subtract, and I'm left with 4 equals 2x minus 8. Step 4 then says to isolate the variable term by adding or subtracting. So I have my variable term, so I need to add 8 to cancel that. Do that to both sides. I'm left with 12 equals 2x. Then I just isolate the variable by multiplying or dividing. In this case, I need to divide. Divide, again, what I do to one side I do to the other, and I'm left with x equals 6. Step 3, which says group variable terms to one side, because again, it's greater than -2. So I need to add 2x, add 2x. I'm left with 20 equals 5x minus 30. Then step 4 is isolate the variable term by adding or subtracting constants. So I need to add 30. Again, I'm trying to isolate this. Add 30. Then I'm left with 5x equals 50. Divide by 5, divide by 5. And 10 equals x. Same process for this last one. Step 1 is to distribute. 6x minus 2 equals 2x plus 1. My x is greater. There's no like terms, so I can skip step 2 again. Step 3, group variable terms. I'm going to make the left my variable term, this side, or the variable side. So I need to move 2x over. And I'm left with 4x minus 2 equals 1. Now I need step 4, it says isolate the variable term. So I'm isolating this, so I need to add 2, and I'm left with 4x equals 3. And then I divide by 4 to get x equals 3 over 4. Question 13 asks us to translate the following sentences into equations. So if I have the product of 5 and the sum of 2 and x is equal to 15. I know that is equal to 15, so equal to 15. And then I have the product of 5 and the sum of 2 and x. The sum of, I know I'll need parentheses, so sum is addition 2 plus x. And when I'm taking the product of something, I'm multiplying, so I'm going to have 5 on the outside of my parentheses to be multiplied by all of that. My next one, I have 4 more than the product of a number and 6 is equal to -2. The is equal to -2 is easy. 4 more than, so 4 plus, and then the product of a number and 6. A number would be our variable, and 6, so we'll just have 6x. Remember, a number next to a variable is multiplication. Part 3 says the sum of x and -3 is equal to -6. Sum is addition, so x and -3, and then the is equal to -6. And this last one is the trickiest one because it says 8 less than. When you have less than, it is reverse order. Think, how much is less than my age? So I need to have the quotient of a number in 4, so x over 4. Remember, quotient is division, so I'll write it as a fraction. Minus 8 is equal to 2. You have to rearrange the order for this one. Part 14, we're going to find the coordinate of each point. That's going to be on our next page. Remember, it's left or right, then up or down. So part A, I'm to the right 3, up 2. So my order pair is 3, 2. For B, I go over 5, down 7. So it's 5, -7. Remember, left or right, then up or down. So the rest of them are as follows. 3, 9, -3, -5, 7, -1. For F, we got -10, -3. G is 8, -2. H is -4, 6. I is 7, 3. J is -5, -5. K is 8, 10. And L is -10, -10. Remember, left or right, then up or down. Skip problem 15. Problem 16, use the table to answer the questions below. That's going to be on our next page. It asks us at the top, use this table, it gives the altitude. And part A says the top of a hill rises 472 feet above checkpoint 2. So I have checkpoint 2, and then it's above it, so we'll add 472 to it. So I have -197 plus 472. I have more positives than I have negatives, so how many more do I have? I'll find the difference between those. 12 take away 7 is 5. I gotta borrow again. 16 take away 9 is 7. 3 take away 1 is 2. So it's 275 feet above checkpoint 2. Checkpoint B says how much higher is checkpoint 5 than checkpoint 2. Checkpoint 5 here is -104. Checkpoint 2 is -197. I'm going to take my bigger number, which is 104, minus my smaller number. That's keep, change, change. So I have 197 to find the difference between them because I have more positives than I have negatives. So I know my answer is going to be positive. 7 take away 4 is 3. 9 take away 0 is 9. And 1 take away 1 is 0. So it is 93 feet higher. Problem 17 is using the same table below, and it says how much higher was the 6 a.m. temperature in Atlanta than Boston? Atlanta and Boston. Atlanta, it was 69. Boston, it was -4, so I have 69 minus -4. I'm finding the difference between them, so you subtract. Keep, change, change. 69 plus 4 is 73. Think on a thermometer. Boston's down here at -4, 0, and here's 69. To get from 0 to 4, that's 4 degrees. And from 0 to 69, that's 69 degrees. So I combine those to get the 73. Part B says by noon, the temperature in Fairbanks had risen by 11 degrees. So -34 plus 11. Think money. I'm in debt $34. I add 11 to that. I pay back 11. I'm still in debt, but I'm only in debt $23. Or in this case, 23 degrees Fahrenheit. -23 would be the temperature by noon.